Hello student. So this session will be for the electric potential. Okay. So I'll give you the brief introduction and I'll just highlight the basic concept of the electrostatic potential. Okay. So as you know that potential, this word you have listened in class 11 when we are discussing the conservative force field, that is the gravitational force field, right? So that time we discuss about the gravitational potential, right? Similarly, in class 12 when we are studying the electrostatic part of that, we are introducing the electrostatic potential. Okay, so this electrostatic potential, it will be helpful for the different calculation, and this is an scalar quantity. So it will be it will be avoiding the the vector on that case, and it is helping in the different mathematical calculation. And also I'll show you some example. Okay, so that where we are using the electric potential. So there are three things like potential. Before that, work done in moving a charge from one position to another positions, right? So, and work done, what is the basic definition of work done? Force into displacement. So here for electrostatic force, the force is the electrostatic force, right? And the displacement is the movement of the charge from one point to other point. So work done will be that. Now from here we will be moving to the potential, right? Electric potential. So that will be the work done per unit charge. So this work done per unit charge is a constant quantity. It will be defining an the electric field, right? Next is the potential difference. So potential difference is that as I told you that the difference between the 2 points of the electrostatic potential, that is again the work done per unit charge, right? And also for us, you will be getting some different kind of calculations, like you will be receiving the electric field and the displacement vector, and you have to calculate the work done. Okay, so in today's lecture, just we want to understand like what is electric potential. So before going that, so we are having the electric force, the electrostatic force. Next is the electrostatic field, then electrostatic potential. Okay, so I am moving my camera to my another screen. Okay, so I hope you can able to understand. So let me zoom it out. Yep. So here work done is equal to force into displacement. So work done, force is that electrical force as I told you, and dl is the displacement. Okay, so work done is for external force and displacement is the dl displacement, for which, like if there is any electric field we have, so we are taking a charge from this point to this point. That time we are doing the work done against the electric force, right? So let's say electric force external is equal to QE. E is the electric field vector and F is the electrostatic force, right? So whenever I am moving a charge from this position to this position, so I am doing an external work against the electrostatic force, right? So this is the work done. So here F is equal to QE and minus sign, like the this force we are applying in the opposite direction. So this is the formula of the work done in case of electrostatic field, right? So this is very fundamental formula. From here, next is the electrostatic potential, right? So potential means work done per unit positive charge, work done per unit positive charge. So whenever you are saying that will be like W by Q, right? So it will be W by Q. So this will be the electrostatic potential, W by Q, right? So whenever you are saying that W by Q, that means the formula of potential will be V is equal to minus E dl. E is the electric field, right, and dl is the displacement vector, the change of positions, right? So here we are saying that potential means we are taking a point from infinity to a certain point P. That time work done per unit positive charge in taking a certain charge from infinity to a certain distance in an existing electric field. Okay, so that is the electrostatic potential. Now what is potential difference? Okay, so let me highlight. As I told you, potential difference means work done by external agent when it is moving the charge from position 1 to position 2, work done per unit positive charge. So that is V2 minus V1 is equal to EDL. So this is the formula for the potential difference. And so these are the things, like friends, these three are very important, and the conceptually, sometimes you are getting confused, like so these are the major conception. Like first is work done is equal to force into displacement. Then force is the electrical force, electrostatic force. F is equal to QE, as I told you, right? F is equal to QE. Now from this work done, we are getting the electrostatic potential, work done per unit positive charge. That means W by Q. So this will be the constant ratio. In presence of an electric field, this will be fixed. Whenever we are bringing a charge from the infinity to a certain distance, so work per unit positive charge, this will be fixed. So this will defining the potential of an electrostatic field, right? So potential, electrostatic potential is a scalar quantity. Next is the potential difference. That is the difference in electrostatic potential whenever we are just taking an object or any charge from one position to another. So W external work by Q, right? That will be equal to V2 minus V1. Fine. So now let's do a calculation, one single numeric, right? So it will help us to the application part. Okay. Fine. So we got a numeric, like work done for shifting a charge. I hope you can able to see the screen. Work done for shifting a charge Q in the electric field from point P to point Q. Okay. So let us show the scenario here. Let's say there is an electric field. Electric field is given here. Electric field is 10 to the power 3 I cap V by M. So this is the magnitude of the field, and this is the direction of the field, right? So I cap is that means it is in the x directions only. If electric field could have like 10 to the power 3 I plus j, that means this field will have the component both in the x axis and the z axis, like x and y or x and z, ij, x and y, two components, right? So here it is mentioned 10 to the power 3 I cap. That means this electric field having the direction in the x axis only. Now next is that the charge which will be moved from position P to Q is 1 microcoulomb, that is given, and charge will move from P to 5 to Q 58. So electric field is present here. In this present electric field, a charge Q will move from here to here. Now we have to calculate the work done in this scenario, right? So we have to calculate the work done in this scenario. So then what is the the formula we'll be using here? As I already told you, the work done is equal to EDL, right? So it will be QEDL. Okay, fine. Yeah. So we are moving slowly because this is the introductory class. As I told you that work external is equal to minus Q EDL, right? Minus Q EDL. So E is the E I cap, DL is the, let's set a DXI and DYJ cap, right? So it will be minus Q E, let's take X component with I cap with the dot product, right? This is the dot product, and DL is equal to DX I cap plus DY J cap. So if you do the dot product, So what we are getting that I dot I is equal to 1 and I dot j is equal to 0, the dot product, right? So it will be only the x component here. So it will be minus q ex dx x1 to x2. So movement will be in the x directions only, right? So ex is the this magnitude, and the point mentioned is 2 5. So what will be there? So the next part, I hope you can able to see this part. Okay. So it will be, your work done will be W is equal to minus Q, then EX, then it will be x2 minus x1. So Q is given 10 to the power, Q, the point value Q is microcoulomb, right? It is 1 microcoulomb. So it will be like 10 to the power minus 6. Ex is 10 to the power 3. And x point is, it was, I think, 25258. So 5 to 8. So it will be 5 minus 2, right? So this will be the work done. So joule, right? So it will be minus 10 to the power 3 into 3 joule. Okay. So this is the work done. That's it. So please watch my session. In the next session, I'll come with some few other numerical. So our target is to actually understand what is electric potential, because this is very confusing part. We are forgetting multiple times, but yes, we have to remember that this stand up on the conservative force field. So electrostatic force is the conservative force. That's why we can introduce the electric potential. And also the next class, I'll just help you to understand the electrostatic potential energy. Okay. Thanks for watching. Welcome to Chatterjee Academy, and please subscribe so to follow the next update, and I'll continue this pure conceptual sessions. Okay. Thank you.